Let's take a look at interest rate options, specifically interest rate caps, floors, and collars. Now, an interest rate cap protects against higher interest rates, and it's really like a portfolio of European call options on an interest rate. Each one of these individual options is known as a caplet. Now, a firm might have a floating rate liability that requires semi-annual interest payments. So the firm could buy a cap on the notional principal to keep from paying more regardless of how high interest rates go. And each one of these individual options would be set up to expire in correspondence with when the semi-annual interest payments are due. So let's take a look at a graph here. And again, you can see this looks very much like the payoff for a European call option with an exercise price of 7%. If the interest rate is below 7%, the option expires worthless. If it goes above 7%, then the long interest rate cap holder receives a payoff. Now, keep in mind that the cap buyer has to pay a premium to acquire the cap, so after accounting for the premium, the effective interest rate is somewhat higher than the exercise price. Now, of course, if there's a firm that's engaged in the long interest rate cap, then there has to be someone on the other side of the transaction, and the short interest rate cap looks like a short position in a call option. If the interest rate is below the exercise price of 7%, the option expires worthless, and if the interest rate goes above 7%, then the writer of the interest rate cap is going to have to pay out an amount of money. Now, an interest rate floor has the same analogy as the interest rate cap. If the cap looks like a European call option on the interest rate, then the floor is very similar to a European put option on an interest rate. And each one of these individual options is known as a floorlet. Now, a bank might have a floating rate mortgage portfolio in which the average rate is 7.25%. But the bank's going to earn less if interest rates decline. So what the bank does is the bank enters into a floor with an exercise price of 6.5%. So the put writer will pay if the rate falls below 6.5%. So if we look at a graph of this looks very much like a European put option, a long position in a European put option with an exercise price of 6.5%. If the interest rate is above 6.5%, the option expires worthless. If the interest rate falls below 6.5%, then the firm that has the long interest rate floor position will receive a payoff. And of course, if there's a long position, there has to be someone on the other side of the transaction. The short interest rate floor looks like a short position in a put option with an exercise price of 6.5%. Again, interest rate above 6.5%, option expires worthless. If it goes below 6.5%, then the writer has a payout, has to pay the individual or the firm that has the long position. How do you calculate the cap and the floor payoffs? Well, I'm just going to do one example, but here's the general formula. The cap payout equals the notional value times the days in the payment period divided by 360 times the benchmark minus the striking price. The floor payout looks similar, except the payout, everything here is the same, except it's times the striking price minus the benchmark. So let's look at an example of a cap payout. So suppose a $10 million cap has a 7% exercise price with the caplets expiring approximately six months apart. So again, the idea is to have these expire when the payout is due. At the expiration of the first caplet, the benchmark rate is 7.13% with 182 days in the payment period. Then the cap payout's going to be the notional value, 10 million, times 182 over 360 times 0.0713, the 7.13%, minus the strike price of 0.07, and if you work that out, that works out to $6,572.22. Finally, let's talk about an interest rate collar. And an interest rate collar is a combination of buying a cap and selling a floor to reduce the cost of the strategy. Very similar to the case where someone engages in a bull spread or a bear spread. Why do they do that? They do that to reduce cost. Now, it means giving up some of the upside potential, but that's in exchange for a lower position cost, because the firm or the individual engaging in this interest rate collar is going to receive money from selling the floor, and that's going to be used to reduce some of the cost of buying the cap. In fact, depending on how the collar is set up, it may be a zero cost cap. So let's take a look at a picture here. This is the case where there are two strike prices. This is where the short floor is, and that has an exercise price of K1. And up here we have the long cap, which has an exercise price of K2. So the two interest rates are different. I suppose you could set them up with the same interest rate, but here we don't have it as the same interest rate. So if the interest rate goes above K2, then the long cap position pays out and there's a cash inflow. If the interest rate falls below K1, then there's an interest rate outflow, or I'm sorry, a cash outflow, because the short floor position requires a payout. And if the interest rate stays between K1 and K2, there's no payout at all. So this is a case where both of these positions expire worthless. And again, it's a good position to take because it reduces the cost, and oftentimes a firm is willing to give up some potential gain just to reduce the cost. In the same way that engaging in a bull spread reduces some of the upside potential but makes the strategy much less expensive.